Hello everyone, my name is Hayley and this is my engineering design project. For my project, I decided to create two separate wrist braces. One is a softer portion and then the second one is a more sturdy splint-like portion. My goal was to make them more comfortable and versatile than braces that are currently available to consumers. These braces can provide pain relief and much needed support to individuals suffering from things like wrist sprains, carpal tunnel syndrome, arthritis, anything like that. Of course, it is important to note that braces are considered a temporary alternative to surgery. However, some people cannot afford these expensive corrective surgeries, so these help alleviate their pain. This project took me approximately 5 weeks to complete, and the initial testing that was completed in this time demonstrated that this is a very promising project. Here's what I consider the soft portion of the brace. You can see that there are quite a few straps all along the brace, and these are just pieces of elastic with fabric sewn on them or Velcro sewn on them, and the goal is to hold the wrist in a neutral position. The right picture just shows what the brace looks like with the protective slip on it. This is the splint-like portion of the brace. This is the much sturdier one. You can see that little almost like pouch on the palm. That's where the 3D support goes. On the left here, we have a demo video for the soft portion of the brace. That bottom strap there, that elastic piece, the thick one at the bottom, that one is actually sewn to the garment so it won't move. You start by doing an upside down U configuration with the first strap, and then you go into a half figure eight configuration. This is another thick elastic. This really compresses just below the palm there. That's a major point of pain for a lot of people. And then that final strap really hinders side to side movement to try to keep the wrist in a neutral position. The slip just goes over that to prevent any Velcro from snagging on things like fabric. On the right here is the splint-like portion of the brace. Here is one of the 3D printed supports. This one goes on the ulnar side of the wrist. And then here's the second one. This one's a bit wider for a little bit more surface area on the palm. You can just slide this one on and you can tighten it by pulling the elastic cord. And then the lace lock, you just pinch the two plastic pieces together and then you can make it tighter or looser by moving it up or down. And then that little extra cord piece can be tucked into a little pouch you can see right there between the leather and the foam lining. This is what my engineering design process looked like. For the first step, I kind of used my own experience to come up with the project idea. I've been suffering with wrist pain since I was about 16 years old, so this was something that I had some experience with. I bought a brace off of Amazon, but I only wore it for a few weeks because I found that it was very uncomfortable and I never wanted to wear it out. I also investigated human anatomy as part of my research, and I looked into a lot of studies that were done previously on other wrist braces or similar treatments. They recommended that the wrist be held in a neutral position to alleviate pain, so that was kind of the basis for my whole design. And then I defined the problem for these braces as being uncomfortable with limited wearability. So the uncomfortability made individuals not want to wear wrist braces, and then the limited wearability really hindered any possible benefits from wearing a brace. Here's some examples of wrist braces that you can find at Walmart or on Amazon. Here's some basic anatomy for you guys. As you can see, the wrist and the ulna kind of form a straight line, and it's recommended that in order for the wrist to be in a neutral position, this be a straight line at the bottom. So that's kind of what we're focusing on here. The thumb and the radius do not have to be in a straight line. That wouldn't make very much sense anyways, because the thumb naturally likes to point out. For step 2 of the engineering design process, I came up with ideas that might help remedy discomfort associated with wrist braces and their limited versatility. I really wanted to focus on material because that could really make or break the brace. A lot of them are very plasticky and not very comfortable. I also wanted to use a foam lining to create a barrier between the individual and the brace. In order to increase wearability, I decided that having a portion for night and day might increase the versatility of the product. I was inspired for the soft portion of the brace by taping techniques for wrist brace or for wrist sprains and things like that. Wrist sprains, thumb sprains, they all use like KT tape, and so that's what I simulated. The second portion of the brace was modeled after splints used by EMTs to immobilize wrists. What is called a SAM splint, which you can see in the middle here, that orange thing, that can be molded around the wrist and the arm when an individual gets injured. The photos on the left and the right with the white tape, those are common taping techniques. For the third step of the engineering design process, I actually had a really hard time with this one. I had a hard time choosing the best brace design. That's actually why I ended up choosing my 2 favorite designs. In the beginning, I thought it would be good if they were worn at the same time. However, by the end, I realized that was not a good idea. It's better to wear the soft one during the day and then the hard splint-like one at night. I really wanted to focus on a neutral wrist position, having foam in each design, and increasing the length of time that an individual could wear a brace. For example, if they only wear it at night, that would be approximately 8 hours. But if they had a design for the day and the night, then hopefully they would get closer to 24 hours of wear. Here are a few sketches. On the right are the different supports for the splint-like brace, and then the left we have my initial designs for each of the braces. For step 4 of the engineering design process, I decided that it would be best to make prototypes of each brace. The soft portion consists of spandex, foam lining, Velcro, elastic, and thread. The splint-like portion used leather, foam lining, 3D printed supports, thread, eyelets, and elastic cord with locks. I used a sewing machine as well as hand stitching to construct these prototypes. The 3D printed supports were printed by a 3D printing company. Here are the basic steps that I used to create each portion of the brace. Won't bore you too much with that. For the last step of the engineering design process, I came up with a handful of tests that would evaluate the performance as well as how comfortable these braces are and whether or not they achieve the goals that were originally set out for them. This included sleep tests, pain scale evaluation, which this was on a scale of 1 to 10. Exercise tests, activities of daily living tests, range of motion evaluations, and fine motor skill evaluations. We can take a look at the results on here. This is my final design paper. As you can see, I have pictures of both of the braces as well as the different elastic that was used in the proper configurations. I even have pictures of the supports as well as the finished product. When we go down to test and evaluation, we can see that the sleep results for each of the braces did not seem to hinder an individual's ability to fall asleep. There's really nothing negative that occurred in this section for the sleep results. They both performed as expected. As far as the pain scale evaluation goes, wearing the soft brace at night really didn't make a big difference. However, that's supposed to be worn during the day, so I didn't really think much of it. The splint-like brace, however, seemed to alleviate some pain, which is very, very promising. The range of motion results, the splint brace really hindered movement, but this is why it's suggested that it be worn at night, because it does have the ability to hinder motion. When we go down to the exercise results, we can see that it was not possible for an individual to do a 1-minute plank while they were wearing the splint-like brace. This is because the palm support hinders that position. You couldn't really do a 90-degree with your wrist. However, you can take the palm support out, and then you are able to do the plank. As far as activities of daily living goes, the splint-like brace did hinder fine motor skills like writing. However, this is not considered a negative thing because the splint brace is supposed to be worn at night and writing really wouldn't be occurring during that time. I just wanted to highlight a few important design changes that I made. In the beginning, I didn't have a Velcro closure on the soft brace. However, I added one because it made it much easier to put on and off. I also thought tension, like high amounts of tension, would be the most beneficial. However, I discovered that is not the case. There's definitely a threshold for comfortability. And as far as the splint-like brace goes, originally the supports were going to be 5 inches. However, that hit at a really weird spot on the wrist, so I decided to change it to 6 inches. And then there was supposed to be paracord instead of elastic cord, but I found it really difficult to tie with one hand, so I changed it to an elastic. On the left here, we have a range of motion evaluation for the soft brace. And then on the right, we have the splint-like portion of the brace. As you can see, it's much harder to move in that brace. That's what we want. That's why you wear it at night, because it really helps healing.